So we want to see static routes. As I've said before, static routes, manually configured routes. So let's see how to do that. So the implementation of routes within the IP routing table of a router can be defined manually using static routes or through the use of dynamic routing protocols. Manual configuration of routes enables direct control over the routing table, however, may result in route failure should the router's next hop fail. So that's one of the biggest disadvantage of manually configured routes. It cannot change. So the configuration of static routes, however, is often used to complement dynamic routing protocols to provide alternative routes in the event dynamically discovered routes fail to provide a valid next hop. So the knowledge of the various applications of static routes and configuration is necessary for effective network administration. Upon completion of this section, you will be able to a volunteer, just unmute your mic and go ahead.
1. Explain the different applications for static routes. Successfully configure static routes in the IP routing table.
Thank you very much, Nick. Just reminding you guys to mute your mic. Okay, so static routes. So we've said, number one, static routes are manually configured by the network administrator. One of the advantages of the static routes is, number one, they do not consume bandwidth. When we learn routes dynamically, we use a protocol, and protocols will have several packet types that also consume bandwidth. Number two, does not consume CPU resources. CPU resources for the router. So when we use protocols like OSPF or ISIS, a lot of calculations goes on in creating what we call the shortest path tree. So with static routes, you don't have such calculations. So those are some of the merits for static routes. Demerits they require manual reconfiguration in case of failure. So that's the biggest problem. Therefore, it is recommended that you use static routes. Use static routes only on small networks. With simple structures. Small networks with simple structures. So don't forget that. Okay. So just to give you an example, if this is our gateway at MMU, and this is what is called the customer edge router or the provider's edge router at our ISP, we might configure a static route to our ISP. Then our ISP now will be able to connect us to the internet, because if we need to go to the internet, we need to go through our ISP. Therefore, we can configure static route between the MMU router and the KNet router. And most of the time, this particular router is referred to as a CE, as we are going to learn when we do MPLS, the customer edge router, while this router here is known as the PE, the provider's edge router. So let's look at static route behavior. Generally, when you're connecting two routers using a serial cable, most of the time this kind of network is referred to as a point-to-point network. Point-to-point. Point-to-point network. Reason being, when you're using a serial cable to interconnect routers, you're only interconnecting two routers. You cannot interconnect a third router. Like, this is what I'm saying. You cannot pull another cable here and you interconnect RTC here. So that's why it's called a point-to-point network. Okay. Oh, let me just redo. Okay. Now, on the other hand, anytime we are using an Ethernet cable to interconnect routers, that kind of network is normally referred to as a broadcast network. Why? Because in a broadcast network, here we can pull a cable and have another router here. And why is it then referred to as a broadcast? We know that if a packet is placed on this shared medium, it will come to this guy, it will also come to this guy. Then each one of them will process based on the destination IP address of that particular packet. So we configure static routes differently on each of these networks. So for example, in broadcast networks, if we are in RTA and we need to configure a static route to this network, we need to specify the address of the next hop. We must specify the address of the next hop. Why? Because if we don't specify the address of the next hop, that packet will also be processed by this router. So we must specify, in a broadcast network, we must specify the interface for the next hop. On the other hand, with a point-to-point network, we need to specify the outbound interface IP address, outbound interface. Because it's a point-to-point connection, and therefore, when we send that packet out towards that interface, it's going to eventually reach here. The other reason also, we have to define only the outgoing interface when we are using a serial connection, is because point-to-point networks use what we call PPP. There's an entire topic about point-to-point protocol that we're going to learn about. In PPP, they negotiate what we call PPP negotiation, and it's through this PPP negotiation that RTA, for example, here will learn the IP of RTB. So for that purpose, we cannot really in this serial connection, we are not really aware of the IP address of this particular interface. Therefore, the only thing we can do is to specify the IP address of the outgoing interface. So it's important that we know the difference between these two networks and how they differ in terms of when we are configuring the static route. So let's see that. Let's see that in practice. So of course, I've already explained this. I've already explained this in the previous slide, that forwarding of the packets over broadcast networks such as Ethernet require that the next hop must be defined. So you must define the next hop. You must define the next hop. If we want to come to this from RTA, you must define the next hop so that it is forwarded to that next hop. Otherwise, it will also come here, and it will not be processed. So you must define the next hop. Okay. So how do we configure a static route? We have three variations depending on we have three variations depending on, number one, whether the network type is broadcast or point-to-point. So that is important. So I really don't like this example here because I don't know. They also included the Ethernet. They also included the Ethernet one here. So let's just assume this in the meantime. And now we do this. So we are in RTB. We can see that from this prompt. Now in RTB, we want to configure a static route that can come to this network here, 192.168.1.0. So how do we do that when we are using a point-to-point network? How do we do that? This is how we do it. This is how we do it. Like this. So the command to use, IP route static. Then number two, you specify the network address. So where do you want to go? 192.168.1.1. Then number three, you specify the mask. So this is the mask of that network. So you can specify it as 255.255.255.0, or you can simply specify it as 24. So space, then 24. And lastly, when you're using the point-to-point, you specify the name of the outgoing interface, name and number. So in this case, in order for us to come to this network, we need to send that packet out towards this interface. So that particular interface is what we're calling serial 1/0/0, this one here. So I hope that is clear. Now let's look at an example. So now let's assume that here now we are using an Ethernet cable. So just straight like this. We are using an Ethernet cable. So how do we configure it? When you're using an Ethernet cable, it becomes a broadcast network. So this is how we configure a broadcast network. Again, you start with the keyword IP route -static, the network where you want to go, and the mask. Then you specify the next hop, the next hop. So in this case, our next hop is this interface here, whose IP address is 10.0.12.1. This one here, 10.0.12.1. So I hope that is clear. That is how you configure a static route. And okay, good. Yes, Oyo?
Hello?
Yes, go ahead.
I want to ask you something about if you consider the router B, the IP address given there is 192.168.1.0. So we take it as the outgoing from this point.
Uliza tena,
Or
hebu
where-
sema tena, ati?
I'm asking,
Uh-huh.
how have you come up with the IP address 192.168.1.1.0?
It is where we want to go to.
Oh, it's where we want to go to.
Mm.
Okay. Thanks.
Someone else raised up their hand? I can't see you. I'm seeing two participants raised hand. Did someone else raise their hand?
Yes, sure. Nick,
Okay, Nick, go ahead.
just wanted to ask for the IP route. Do we use like the gateway of the route, the router you want to send the data to? Because actually, I'm asking whether we use the gateway of the like for router A. Are we going to use the gateway for the router A? And do you know which IP I'm going to use?
Wow. I'm really unable to comprehend your question. I'm sorry about that. The router itself is what we call the gateway. So what do you really mean? Do you mean
No, I think you have already answered me. I think you have already answered me. If the router is the gateway, I think I've understood.
The router is the gateway, and therefore, if we have two end devices that are connected, if we have two end devices that are connected to RTB,
yes,
then these end devices will have an IP address. For example, this one can be 192.18.2.2. The other thing it will have is the gateway address. So 192.168.2.1. Are you seeing that?
Yes.
On the other hand, this guy here will also have an IP address. Maybe 192.168.2.3 and also configured gateway address, which will be 192.168.2.1. So by .1 I mean this interface here for the router has been configured with .1,
Yes.
Like that. So that one has been configured with .1. So that is our gateway. So now, once we've configured RTB with this static route, once we've done that configuration, then these guys on this network segment can be able to ping computers on this network segment. So really that is what we are doing. They can be able to reach.
Okay.
Umenielewa?
I understand.
But now, again with static routes, you need to configure on both direction. So saisi tumeconfigure a route from RTB to this network.
Yes.
So for these guys to get the reply, so the request will go, the ICMP request will go, but they can't get a reply until in RTA again, you configure a route from RTA to this network. So that is when now these devices can be able to receive a reply. Okay. So you're going to do that during the lab. Now, there's a concept of load balancing. I already talked about load balancing, but I'm just saying it here again. So in this particular case, these two routes have the same longest match. They have the same longest match. We can check by the slash here. They have the same longest match. They have the same preference because both of them have been configured using static routes. And they also have the same cost because both of them are using gigabit Ethernet links. So they have the same cost. So as we said in the previous chapter, If they have the same everything, then the routers are going to do load balancing. Load balancing. So I hope that is clear. So we can always verify that indeed they're going to be load balanced by displaying the content of the routing table. So display IP routing hyphen table. We can see that the destination network is 192.168.1.0 from RTBA. How did we learn that route? Through static. The preference value is 60. The cost is 0 because it's a directly connected network. And we can now see that both next hops have been added. And the outgoing interfaces are also different. So we can go through this next hop or through this next hop. So I hope that is clear. I can just go back. So that we see the next hop. So we are in RTB. We've configured this. We want to go to this network. From RTB, we want to go to this network here. We want to configure a static route to get us to that network. So look at the next hop. We configure the next hop. So we can either come here, 10.1.0.12.1, or we can also use this. So we've configured both of them. So only the best will be installed in the routing table. But in this case, both of them have equal weights. So both of them are installed in the routing table, as you can see here. Okay. So there's also a concept of floating static routes, very important. Floating static routes is easy because it's simply altering the preference value of one of the static routes so that it can act as a backup. So you don't want that route to be installed in the routing table. So in this particular example, we want to change we want to change the preference of this route to a higher preference value so that it can act as a backup. So for the first route via the 10, this one here, via the 10.0.12.1 network, we configure it normally. We know that the default preference value for static routes is 60. But now, when we are configuring for the next one via the 20.0.12.1 network, we add in front of that, this is supposed to be on one line. So in front of this, you put a space, then you enter the keyword preference, then 100. So now the preference of this route is 100. And therefore, it is not going to be installed in the routing table. So if we check that, if we confirm that by typing display IP routing table, we can see that indeed, only the 10.1.0.12.1 next hop has been installed in the routing table. We can go ahead and shut down that interface that had been installed. So this interface on RTB, the outgoing interface, we shut it down using the shutdown command. So when we shut it down and we do display IP routing table, the other interface, G001, which we configured to have a preference of 100, is now going to be used to forward data. So the one that is forwarding data is called the primary route. Then the one that is acting as backup is known as the floating static route. So when the primary route goes down, then the floating static route picks up. Then we have what we call the default static route. Default static route. The default static route provide a form of last resort in the event that no other longest match is found within the routing table. Within the routing table. So look at this command we are doing at RTA. We're doing this command in RTA. IP route static, then we're using 0.0.0 and 0.0.0.0 as the subnet mask. And we are configuring a next hop. So this is our next hop on RTB 10.0.12.2. Now, can someone remind me, when we were looking at the IP address topic, what did we call the very first address on the IP address range? What did we call it?
Network address.
Eh?
The network address.
Not really. The 0.0. This one, 0.0.0. It's called. It's one of the special IP addresses that you cannot assign to an end device. What do we call it? Okay, so it's called the any network. Any network address. A common question in the exam. The any network address. So, this is the router at the edge of MMU, at the network edge, at the core layer. And then we have this this router here, the provider edge at KNet. So when we configure IP route static 0.0.0, 0.0.0.0, then we configure this next hop. We are simply saying, hey, MMU, when you get a packet whose network you do not have in your routing table, just forward it to me. Forward it to me. So don't discard it, forward it to me. So that is what we call the default static route, used as the last resort. You've gone through your routing table, you've not found that network, then use the default route. Send it to the default next hop that has been configured on the default static route. Why do we do that? We do that most of the time on customer edge routers because customer edge routers most of the time do not, they're low-end routers. So they have minimal storage capacity, minimal CPU power. So most of the time, we don't want to overwhelm them with so many routes. So we don't want it to store all these routes because it's a low-end router. So sometimes for that particular purpose, we might want to configure a default static route. So that is the concept of the default static route. So the default static route will usually be installed again on the routing table. So if we use display IP routing table, we should find it there. Wonderful. So we are done with this topic. Two volunteers who have not spoken since morning to guide us in these two questions. Joshua, you've been quiet. Go ahead with the first one, Joshua.
Okay, what should be altered to enable a static route to become a floating static route? I think it has something to do with is it adjusting the preference value? I don't remember quite well.
Ati, what should be altered to enable a static route to become a floating static route?
Static route.
Someone
Do we
can
add?
ahead, just try it.
Is it the addition of preference value?
Exactly. We should alter the preference value. You see here, we are simply altering the default preference value. The default preference value for static routes is 60. So we make it a higher one so that this route cannot be installed in the routing table.
Okay.
Okay, thank you for that. Bethwell, I can see that your mic is on mute. So just go ahead and help us with the next one.
Okay. Can you go back to
Yes, please. Yes, please.
which network address should be defined to allow a default static route to be implemented in the routing table? I think it was any network address.
Correct. Thank you very much, ladies and gentlemen. Now we go and do the static route lab. So check WhatsApp. I'm gonna update that as we also proceed for our 1 hour lunch break. Asanteni sana.
Okay, a question, please.
Yes, please go ahead.
During the last lab,
Mm-hmm.
I had a problem
Mm-hmm.
whereby in our lab 3.1 si tulimaliza kila kitu tukasave, then sasa nimefungua kwa hii lab ya 3.2 nikarealize ni kama haikusave setting yani, lakini nilifuata hiyo procedure tu bado.
Okay, number one, yesterday I said if you reopen your lab and you find out that the configs you had saved have been lost, try saving on a different location. Save your topo, not topo yako. Save your topo on a different location. So kama ilikuwa inakuwa saved kwa my documents, choose a different location. If possible, a different partition of your hard drive. That is number one. Number two, for each lab, begin your topology from scratch. So do not use a topology for a previous lab. Create a new topology for each lab. So I think I didn't say that. So Bethway, just try that, then let me know. Let us know in WhatsApp if you have an issue. Asanteni. Okay.